So, hi everyone, welcome to this module. It's the second one, and I decided to change design a little bit and to dive deeper mathematically into each machine learning algorithm to build a concrete foundation to iterate through everything and to try to explain mathematically as much as I'm able to. And this module is for linear regression. It's the very first machine learning algorithm that we're gonna talk about. Today I'm gonna introduce a few terms, a few basic ones that everybody should know. And in this module, here is the plan for it. It doesn't look quite huge, and in reality it's not really huge. We're gonna talk about what linear regression is, and what is stochastic gradient descent, and what is Bayes gradient descent, and there is an important thing, an algorithm called least squares method. So this actually thing that lets our linear regression be fitted with data within just one iteration and to be fitted perfectly. And this thing works only with linear regression. So today we're going to talk about some basic terms and two metrics. So firstly, what is machine learning? It's, as you may see, a field of AI where computers learn from data and make decisions and predictions without being explicitly programmed. So it's easy to understand, but actually for those who are tired, like what does it actually mean? It means that we create a huge algorithm. I mean, not huge, like the algorithm that is not related to any kind of data, to any kind of thing that we want to predict. And then we can feed it with whatever data, like if it works with numerical data, we can feed it either with, for example, housing things like amount of square meters, distance from subway, or we can feed it with some human-related measurements like age or the weight. And the algorithm doesn't care about the kind of data, it just learns from it and develops a certain function that is able to take another features and predict some value. So this is what machine learning actually is. And I have mentioned the term model. What's actually a model? It's a function, obviously, that is learned from data that our algorithm it has learned from data, and it then created a certain mathematical function. It's called a model from data that maps inputs to outputs. So this function gets x as an input and then produces the y value, where x is the vector of features for one object and y as the target. It can be whatever, it can be number, class. For cooler models it can be a video or an image, so whatever, you just give it something and it gives you something like an ordinary function. But in terms of it, you just give it some measurements that you know, or whatever you know, and from the features you want to predict something, and it lets you predict it. I'm also going to mention what is a supervised learning. It's a type of machine learning algorithm, obviously, that is linear regression related to. So that's why we're talking about it in this module. So it's a type of machine learning where a model learns from labeled data. What does it actually mean? It actually means that when we feed a model with data, we feed it with features and with targets. So each object corresponds to its target, and the model learns from it to then predict the target from the features. And the next thing is metrics. Those are just measurements to estimate how bad or great our model is, because without any estimations, how can we even know whether our model is great or bad? And we are going to talk about a thing that is almost the same as measures. It's called cost function. It's a metric that indicates how huge the mistake is. We're going to use it later, but it's an important thing, and I think you should memorize what that is. But it's actually unintentionally understandable what the cost function is. And the first metric, we're going to touch two of them today. The first one is called mean absolute error. It's just the mean of all of the errors. And you may ask yourself, and me either, what is an error in machine learning? So imagine a situation, you want to understand how great your model is. You feed it with certain data, and then you have another piece of data that is labeled, obviously, but you can use this data to test your model. So your model is actually fitted. You give it all the access, all of the features. It produces your sum of the sum vector y with predicted targets, and you have actual targets. And if those are, for example, numerical, and this works only for numerical values, when you subtracting y with hat from actual y, you get an error. You get the number that your model have mistaken, the number of points, for example. So it's just the mean value of them. And the next thing is called mean squared error. It's almost the same thing, but it's squared. So we get the mean of the squared errors. Why is it used? Because firstly, it's a convenient thing to do the derivative, and secondly, a huge error affects the mean squared error more. So if we have a huge error, we would obviously see it better than if we had used the mean absolute error. So this is everything for today. On the next lesson, we're going to talk about gradient descent, and we're going to do some mathematics that, from my perspective, is not enjoyable, but I should say that it's, I don't know, beautiful, because there are some algorithms that are actually beautiful and you get something interesting. So I hope you stay with me, click the follow button, click like, and try to comment about what I should change or where I should focus more. So thanks y'all. Goodbye.